Hello everyone, I thought I would give you a video demonstration of our Pearson Correlation exercise. I'm going to just download the zip file for this folder by going to my GitHub repository. Well, I guess I'd start out if this is my repository. If you're going to do this assignment on your own, then you want to have your own GitHub account and go to fork and click that, and that will copy this assignment repository to your account so you have a version to change and upload your completed files to. And then I'm going to go to the green code button and download the zip file for this folder. And when that is done downloading, we will open it up and extract it. And usually in Windows, this pop-up window will come up, and you want to show extracted files when complete and keep that checked, or check it if it's not checked and hit extract. And that gives me my new folder right there. I'm going to go ahead and close that zip folder. We won't do anything else in that. When I get into the folder, I have my answer sheet that has all the instructions. So you'll want to open that up, and usually if you just click on it, your computer will select a program that will open that file. So I think I have Word on this computer, and we'll let that open up. Okay, so we'll go through this. I have updated these sheets to include some basic information you should always thinking about when doing a statistical analysis for real. So usually here's a few things, some suggestions to think about the study overall. And if you were doing this analysis for somebody, you'd want to know, who you're working for, and when it's due. What's the general purpose of the analysis? This is definitely something to keep in mind. In this case, we're just doing a learning exercise, so there's not much to think about there. What are the research questions for this study? In this learning exercise, we're using an example from Andy Field's book. So if you go to Chapter 8, Section 4, you'll see a description there, and you want to keep that in mind. And in this case, we didn't have any research hypotheses. Also something you want to keep in mind, what question you're trying to answer and what you think you're going to get from your analysis. And then what is the study design? And it's always good to identify this when you're analyzing data for real. We're not going to do that here because we're just doing an exercise, but those things definitely have implications for how you interpret your data. Irb issues, if you're analyzing real data, a lot of times this involves people. You want to make sure that ethical standards were maintained. Otherwise, you really don't want to be working on these data or have your name associated with something that was done without following ethical standards. When was the data collected? Again, this is a learning exercise, but something to keep in mind when you're analyzing data. How was it collected? Were good procedures used? And how was the data entered into this format and handled? All things to keep in mind because they're going to impact how you can interpret and trust the results of any analysis from these data. So then we're going to get down to our data set. What are the variables in the data set and the levels of measurement for each one? So here we're going to get into Jamovi and open our exam anxiety.save data set. So I'm going to open up Jamovi. going to go to File, Open, Browse. We need to navigate to the folder where we save this data set, and we're going to open the examanxiety.sav file. All right. So, just skimming through this, we can take a look at these variables. So it looks like we have about 103 rows. Excuse me. That to me looks like an ID column. So I'm going to go open this up, and we're going to identify it in Jamovi as an ID column. Other statistical programs may not have that category, in which case that really is a nominal variable. These are not numbers that we're using to count with. These are just identifiers. They could just as easily be letters or alphanumeric combinations of letters and numbers, in which case that is just a nominal. It's dividing the participants in this data set into groups, and it just so happens that each of these groups has a single member. So that's basically what an ID variable does. So just give each person a unique identifier. So we're going to call that ID here in Jamovi, and we'll go to our next variable on revise, and this is time spent revising. I assume it's probably in minutes. Our exam scores are on the next, and this is a continuous variable. That's definitely a ratio level of measurement. 0 means 0 here, so that's an appropriate measure type here in our data set. And then we have exam performance percent. Again, that is ratio level of measurement, so continuous is the correct measure type. Anxiety, this is a score on an anxiety instrument, and these numbers look like they have quite a range in them, and they have decimal places, so that's going to be interval level of measurement. Again, this is a psychometric instrument, but in Jamovi, interval and ratio level of measurement are both continuous, so that's an appropriate setting there. And we have the sex of the participants. We have 2 levels, male and female, and we see that that is set as nominal. So all of our data, our variables in the data set look like they're correctly set. We can do a little look down, and we don't see anything that looks out of place or missing. But when the data set gets larger, then it's good to get some descriptive statistics. So we'll go ahead and go to exploration and descriptives. And our single categorical variable here is sex, so let's put that in the variables box, and we'll get frequency table. And in statistics, because this is nominal, we don't care about the mean or the median or the standard deviation information, but we would be good to get a plot, so we'll pick a bar plot. So we see in here we have 103 rows, no missing data. There's frequencies and percents for this. It's pretty closely split between males and females, and that shows up here in our bar plot, so that's great. Let's get descriptives for the I don't see any data problems here. There's no misspellings, no extra groups, no strange groups. We'll go to analysis and click on exploration again in descriptives, and you'll see we get a new analysis in our output window, and this time we're going to go ahead and get our continuous variables, and a lot of times it's good to, when we do tests, well, I won't worry about that for right now. When we do tests in the future, if we're going to be looking at things split by groups, we can actually put the split by over here, but we're not going to worry about it because we're just worrying about correlations right now. So here we do want our mean, and we have our standard deviation. We can go ahead and get skewness and kurtosis and see the distributions on these variables. And in this case, we're going to get a histogram and box plot. And we see we have our three variables. We have 103 entries for each one, no missing data. We have means and standard deviations, and this is interesting. So on revise, you'll see we have a mean of 19 and a standard deviation of 18. So things seem pretty spread out here. There's a lot of variability. On mean, with the exam, we got 56 and 25. Not as spread out as revised, but still a pretty decent spread on there. And then anxiety, also a fairly decent size standard deviation. So I'm expecting these histograms to be pretty spread out. We can see our minimums and maximums here. Quite a range on there, 0 to 98. 2 and 1 on exam. And these are percentages. So, so 2 to 100%. Never mind. That's quite a big spread on those. And anxiety, minimum of 0.05 up to 97. Again, quite a good spread on there. And if we're looking at skewness and kurtosis, remember we can look at our skewness divided by the standard error of skewness, and if we take the skewness divided by the standard error, and if it's greater than 2, then that's going to be skewed data, and that's definitely larger than 2. And it's positive, so it's going to be skewed in the positive direction or to the right. Here our exam, 0.3 divided by 0.2, that's not greater than 2, so that shouldn't be too skewed, although it is negative, so it's going to be a little on the left side. And anxiety also quite skewed, but this one is 2 divided by 0.2, so definitely over 2, and negative, so that one's going to be skewed to the left. So if we look at our plots, we can see we have some outliers up here towards the top. So definitely some people didn't spend too much time revising, up to around 20 minutes, but then there are a few people that spent quite a bit more time than that. There's our box plot, and we can see we have outliers there on the top is what we expect. Exam, again, this one's skewed a little to the left, but not enough to be a significant deviation. I guess I could go ahead and get the normality test and see what actually comes up as normal. And all of those are significantly different. And for a lot of our tests, the normality skew is what we care a lot more about. One of the issues with these significance tests for normality is they also incorporate kurtosis, and so it may be significant, but it may not be in a way that we care too much for our tests. So a lot of times I just look at this skewness divided by the standard error of the skewness, but something good to keep in mind as you're looking at some of these results. And there's our box plot. Nothing comes up as real outlier there, not too surprising. And here's our anxiety, and that's definitely skewed to the left or negative, and we have outliers showing up there. All right, let's go back and look at our instruction sheet. So we've got the variables in the data set, and they are set. Looking at any issues, we definitely have some skewed data there. I guess one thing to think about, because correlation is a parametric operation, is, we do have some things that are not normally distributed, and then the question becomes, can we use a Pearson correlation? And when you start considering that, you definitely sample size will come into play here, and we do have sample sizes quite a bit bigger than 30, so these are large, so we're still probably okay to use a parametric operation like a Pearson correlation. But as we get more into parametric tests, that's definitely something that we would want to think about and reason through if this is an appropriate test for these data. So So yes, we do have non-normal data, but we also have large sample size, so we're probably okay to continue doing this test. If you had any data manipulation that you need to do, you definitely want to do that before you continue on with your analysis, but we're not doing anything else here. We have no missing data. We definitely have outliers. We would go through and describe some of those and make a decision on if we're going to keep them in or leave them out. And this is where you would want to go double check, are there any data entry errors? Is there somebody that should or shouldn't be in the analysis? You don't want to exclude an outlier from an analysis just because they're an outlier. That would not be a good statistical practice. You want to have a good reason of why you left them in or why you took them out. So I don't have any additional data on these, so we're going to leave them in the analysis, but you definitely want to go through and list what any issues were and fix them before you do your analysis, because if you have problems, if some of these were typos or entry errors, then you definitely cannot rely on any analysis you do based on that. So you want to fix that before you go through and do anything else. And again, you would have any participant information you would include in a normal analysis. Okay, so now we're going to look at Pearson Correlation here in Jamovi, and one nice thing about Jamovi is it does provide this module StatCat for helping to select the right test. So we're going to go give that a try, and we're also going to install a module called Scatter and get a scatter plot. So we're going to go over here to Modules, Jamovi Library, and we have Scatter installed, but if it's not, install it. And StatCat, let's make sure we've got that installed so we can give it a try. There it is. Update. Okay, we can go to StatCat, go to relationships, because correlations are looking at relationships between variables, and we can just try a couple of these variables in there, and we see that we can do a Pearson correlation, which should give us a measure of the strength and relationship direction of two variables, and then we will talk a little more about regression later on. And there's a nice scatter plot to look at. So StatCat is great for helping us to choose a test. There's a lot of other resources out there, but that is something to work through as you're learning statistics, is what level of measurement you have for variables and what statistical procedures and tests can you do with those based on the level of measurement. So that is part of why we hit levels of measurement so hard at the beginning of this semester, because the rest of what we do is based in that. Okay, and now we're going to get a scatter plot. So let's see what I asked for in the instructions. We're going to get so we're going to get scatter plots for anxiety and exam, revise and exam, and revise and anxiety. So basically the three combinations we can have with these three variables. So we're going to go to Analysis, Exploration, Scatter plot, and we're going to do revise and exam, and I'll go ahead and put a regression line in there. It's nice to look at. And then we want another scatter plot, so we're going to stay on Analysis, click on Exploration again, and go to Scatter plot, and you'll see that opens us a new output. And let's do revise and anxiety and get a regression line in there. And let's get our third one. So we're going to go stay on analysis, click on exploration again, and go to scatter plot. And let's do exam and anxiety with the regression line. So you can play with that a little bit and see how it works, but this is great for looking at relationships between different variables. If you want to change anything about a particular piece of output in Jamovi, you can just click on the one you want to change. It will take you back to that, and you can adjust it however you want. You can try adding in some marginals there, and you can see some box plots against the data on this. That's kind of a handy thing. So there's some nice options here. Okay. So what statistical tests will be conducted? Which variables will we use in those tests? So we'll describe that a little bit farther down. But basically, we're going to get correlations for all of these variables with each other. Okay. Talk a little bit about assumptions of statistical tests. So before we do any testing, we really ought to look at our assumptions. So are both variables continuous? And we did look at that, and they are. So we're good with that. Additivity and linearity. This is something that a scatter plot definitely helps with. Is there a linear relationship here? And it basically is. We can see that down here on the low end of exam, things are a lot less spread out than they are up here. So we might have some issues with homoscedasticity here, but we're going to be okay to walk this through. Again, we have a pretty large sample size, but it could be noted that this does not have very symmetrical distributions from one end to another. Again, here with anxiety and revise, we have basically a linear relationship. There's no obvious curvilinear relationship that would make our results less meaningful. So we're okay, but we do definitely have some outliers here. And here is revise and exam. And again, a little bit of an issue with homoscedasticity, but we do have a large sample size, so we're probably okay. But it could be noted here that the low end on revise has a lot more spread around exam than the high end. So definitely some things to look at. So we have some issues with, so linearity, we're basically okay with our normally distributed sampling distribution. When we have large samples, we basically meet that because of central limit theorem. When we get into more stuff with regression, we're going to see what the errors are, and so we're not going to look at that right now. If we had small samples, then we care more about are the data normally distributed, but we don't. We have a large sample here, so under the central limit theorem, we're probably okay with that assumption. We have definitely starting to violate this homoscedasticity assumption. Excuse me. But we're going to continue on with this analysis. And we know that these are not related data. These weren't the same individuals looked at two different time points or anything like that. So we do have independence of observations. And we do have a good number of outliers, but that would be something we could look at more closely with other things. So now we're going to go through our steps of null hypothesis significance testing. And I've got them listed there. So our null and alternative hypotheses. So the null is always going to be some version of there is no difference. And in this case, we're going to basically say there is no relationship between whatever two variables you're interested in, and the alternative would be there is a relationship. Our criteria for rejection, there are times when you're going to pick something other than alpha 0.05, but we're going to stick with that for our class exercises. So alpha equals 0.05 is our criteria for rejection. Now we're going to calculate our test statistic. So we're going to go into Jamovi and get our correlations. So I'm going to click in Jamovi. I'm here in analysis, and I'm going to go to regression and correlation matrix, and we're going to take our 3 continuous variables, and I can just drag them over if I want to, and we have an option here to get our parametric Pearson correlation, and since we do have skewed data, let's go ahead and click on Spearman. Certainly doesn't hurt anything, and it will give us a comparison between our parametric and non-parametric. This is our non-parametric correlation, and I like to click flag significant correlations, and we know the ends on these, so I'm not gonna add this in, but we definitely could get that if we wanted to. We could add in confidence intervals, and we don't have any preset hypotheses, so we're going to just stick with correlated, and let's go ahead and get a plot, and let's see what that looks like. What happens when we add in statistics? Okay, so what happens when we add in variable densities? So those are interesting. I'm going to take the densities out, but I'm going to leave the statistics in the plots because we can see our numbers right there. So here is a correlation matrix, and in other statistical software, so you'll see we have a Pearson R up at the top and a p-value, and then we have a Spearman row and a p-value. And to make this simpler to read, I'm going to go ahead and take off our Spearman row, but before I do, we can just look and see we have really similar values: 0.397, 0.350, 0.709, 0.622, 0.401, 0.405. So we have, a large sample size, and again, we can compare our parametric and non-parametric, and they're quite similar. So you see we get a very similar result. Always nice to check when you do have some assumptions being violated. But for ease of reading this, I'm going to go ahead and take off our Spearman and just leave this with our Pearson. So you'll see that we have our variables listed down the side, our rows, and then we have some variables listed across the top in our columns, and you'll see they're the exact same variables in the same order: revised exam anxiety, revised exam anxiety. This area down the middle with these dashes is what's called the diagonal on this correlation matrix, and that is where a variable is correlated with itself. And that actually, in many statistical programs, you're going to see ones down the diagonal, and but Jamovi elected to put dashes in here. And then to find the correlation, you just take the row and follow it over until you get the column that you're interested in. So here, to get the correlation between exam and revise, we'll just go on the exam row and go to revise, and we have our Pearson R value of 0.397, and then a significance test of less than 0.001. So that's definitely significant, and we clicked our option to flag them, and you'll see it's flagged with 3 stars, and down here it tells you 1 star is p less than 0.05, 2 stars is p less than 0.01, and 3 stars is p less than 0.001. Here we've got anxiety with revise. Again, our Pearson correlation is negative 0.709. Our p-value less than 0.001, definitely significant. And anxiety with exam, negative 0.441 and 0.001. So also negative correlation, also significant. But you can see these regression lines in here. They also kind of give you a little feel for how strong is that correlation, and the steeper the slope, the stronger the relationship. So we can see that revised anxiety has a pretty steep slope, and if we go look at it here, negative 0.709, 0.7, that is definitely the strongest relationship between revised and anxiety compared to the other 2 correlations. So we calculated our test statistics. So let's focus in a little bit. I just want to get you used to reading the correlation table and the scatter plot. So we're going to focus in on one thing. So anxiety and exam. What is the value for R for anxiety and exam? And if we look at Jamovi, we can go to anxiety and exam, and the value is negative 0.441. If we look at the plot, this is where plots are very useful. We have anxiety and exam, and we can see that it's negative, which means as anxiety increases, exam decreases. And a negative relationship for correlation is always going to have them doing the opposite thing. As one variable increases, the other variable decreases. Just as true to say, as one variable decreases, the other variable increases. So positive relationships, as one increases, the other increases, or as one decreases, the other decreases. Negative relationships, they go in opposite directions. Let's see what else I was asking. What is the p-value? And we'd already seen that that's less than 0.001, so definitely significant. What we conclude about the null hypothesis. So we're going to reject the null because it's low, and I use a little rhyme to help me remember. When the p is low, the null must go. So our p is definitely low, less than 0.001, so the null must go, we're going to reject the null. And a little note about language here, we actually don't do anything to support a hypothesis in this process in null hypothesis significance testing. And so I always stick with the language. We either reject or fail to reject. And in this case, we're going to reject the null. And I don't recommend that you use the language saying we accept the null. I don't recommend using the language saying we accept the alternative hypothesis. This is kind of a logical construct that's been made, and to keep you safe and from people who get very particular about how things are stated, and it does matter. I always stick with the language of reject and fail to reject, and so I would recommend you do the same, but describe it at your own risk on how much you want to take from other people that hear you talk about statistics. So if you say reject and fail to reject, you'll pretty much always be on the safe side of stating that correctly. So in this case, we reject the null, and we conclude that there is a relationship between anxiety and exam. And then some things to look at, and I kind of put these questions under the post-hoc section on this, is what is the strength of the relationship? And as we saw, it's negative 0.441. So you can read in your text or in many online sources a lot of times 0 to 0.3 might be considered low, 0.4 to 0.7 might be considered medium, 0.8 and above would be considered strong. So in this case, I could default and say it kind of has a medium strength relationship. What is the direction of the correlation? And that's definitely negative, meaning that as anxiety goes up, exam goes down, or as exam goes up, anxiety goes down. You can state it either way, but that is the way they're set up. Although one caveat here is this anxiety measure was a psychometric instrument, so you would definitely want to go verify how that is set up, because logically it would make sense if you're measuring something like anxiety that you would make it that a higher score meant somebody was more anxious. But it happens sometimes that things get set up in a kind of counterintuitive format, and maybe they were measuring lack of anxiety, but they only used the word anxiety, in which case lack of anxiety would be a higher thing. And so we kind of made an assumption here, which you never want to make those assumptions without going to check them explicitly. So I'm assuming that a higher anxiety score means that they have more anxiety, and I would interpret that as, I would make a final interpretation. And so I'm asking my last question is, how do you interpret the meaning of the results? And so this is where, my real world interpretation of this is, as individuals experience more anxiety, exam scores tend to drop. Or conversely, as people experience less anxiety, exam scores tend to be higher. And if we look at this, as anxiety is going up, test scores are going down. So those with less anxiety tended to do better on the test. But that real world interpretation kind of forces you to connect those dots in your mind of what this really means. And I would always recommend that you go through that extra step of making an actual interpretation for what you're seeing there. So Field gives some examples of reporting results. If it's a single result, then you're going to want to give the value for R and the value for P. If you're doing APA, these statistical numbers R and P should actually be italicized, something that's easy to overlook in APA. And then describe the strength, direction, and interpretation of the correlation. It's really not enough to say it's a strong relationship or it's a positive relationship. Give that final interpretation to really make it meaningful. Too often people race through it and they give some of this stuff, but do they really understand it? And giving the interpretations where you're really going to show that you understand what's going on here. For multiple results, it's best to report them in a table or table similar. You'll see a similar table in Field's text, and these guys have made this so you can really about copy and paste this out of here and put that in a report. So reporting in this format is recommended for multiple correlations. It's just as easier to read and is what people will be used to seeing. Okay, so we're going to save our Jamovi file and our output. So if I go to save this, I'm going to go to my file menu and go to Save As and Browse. And I'm going to go to, I'm here in my folder, it's still in the right one. Sometimes you want to double check. I had some issues with that with earlier versions of Jamovi. I'm going to have a name here. I'm okay with that name, and I would click Save. It's going to give me the OMV file. I'm just going to cancel because I don't care about saving this for myself. And export your output. So click somewhere in the white space and go to All and Export and go to Browse. You want to make sure you go back to your correct folder and give it a name, and this is going to be a PDF document. You're going to turn both of those into your repository. I'm going to cancel because I don't want to save it. So that gave us what we needed there. Now we can go back to our folder and we can look on our instruction sheet just to make sure we're following all the right steps. Now we're going to open the RMD file in RStudio. So if I go back to my folder, and there's my R notebook, my R markdown document, and I'm going to right click on that and click Open With. And I want to go to RStudio and click OK. Alright, so I'm going to make that window just a little bit bigger. You'll see my correct folder came up, so that's handy. So, and when I first made this, I actually didn't find how to do a scatter plot in Jamovi. I subsequently went and found that module. But I went ahead and left this code in here so you can see it. Here, Okay, so you'll see I gave you some code for doing some plots, but I actually didn't give you the code to open the data file. So this is where you'd have to do a little bit of thinking and figure out how would you open the data file. There's quite a few ways you can do this, but I just went and found one of my old assignments, and I'm going to copy the code from my old assignment and paste it in here. And I want that in my data set. So we'll see if I can do this in the live demonstration without messing things up. Okay, so I went and found one of my older assignments, and I went and got that code. So we're gonna run our regular packages here, and we'll run our check to see if our packages are installed, and they should be. And you'll see that no installation happened, and it listed them out for me. And now I'm gonna use them. And now I'm going to go to opening my data set. So in this case, the file that I want is called examanxiety.sav. So I need to fix that in my code here. So under line 51, data set, I'm going to change that to match the name of the data file that I have. Examanxiety.sav. And now I'm going to run that. And now you'll see that it did, in fact, import my data set, and I can click on that and see that. Okay, so let's see. Now these are using, so you'll see this is actually using a data set called data. So I think what I'm actually, rather than go change all this code, I'm just going to change this variable to something called data instead. And you'll see I have my new variable named data. It's the exact same data, but it's going to be in the name that works with what I had here. And if we go run this code, see how we do. And you'll see that I got several different plots out using some of these examples. And you'll see that these look very similar to the ones in Jamovi. I wondered when I found this if they actually used this package when they were creating that, but you'll see that our plots we get in Jamovi are very similar to these. That is an example of, and then we're going to, of course, knit this to a markdown document. So we'll click on our knit to markdown and let this run for a minute. This takes a minute to run. And you can see it was working and putting some files into my so there's my markdown document that got saved in my folder. So I'm good with that. And so finally, I'm going to minimize some of these folders and files. And well, let's do our last check on our instructions, make sure we got everything. I'm fairly certain we did. So complete the steps in our markdown file, and after you finish reading through the R markdown file, knit to a markdown. We knitted to our markdown, so we're okay with that, and we have it saved. And then we're going to load our RStudio and Jamovi files to our GitHub repository. So I'm going to go to Add File, Upload Files, and I will go to my folder, and I'm going to drag my markdown document and I would have my PDF and my OMV files, and I would drag them over there too. I didn't save them, so that was my bad, but you should have saved them, and drag your PDF and your OMV files over to here, and you'll see them listed here, and you want to click on the green Commit Changes button and hit Cancel. And that is how to do this correlation exercise. Have a good day. I'll talk to you later.